I remember my humble self, Mr. Wise One. I have a question here on physics. It's under heat capacity. Let me quickly go through the question. As I'm going through the question, I'm bringing out the parameters involved in the question. 100 gram mass of steam, that's mass solution. Okay, 100 gram mass of steam. So my mass is given. Mass is given as what? 100 gram. Remember, I need to convert this 100 gram to what? Kilogram. So 100 divided by what? 1000. What will I have? 0.1 kilogram. Okay, so of steam was cooled to a temperature of 25 degrees Celsius. That's the initial temperature is given to us as well. Theta 1 is what? 25 degree what? Celsius. Calculate the heat lost to the surrounding. So I'm looking for what? Heat lost. So my heat lost is what I'm looking for. It's unknown. Okay, latent heat of vaporization of steam is given to us. That means my LV is equals to what? 2.26 times 10 raised to the power of what? 6 joule per what? Kilogram. Specific heat capacity of water is also given to us. That's my C. It's given to us as what? 4,200 joule per kilogram per Kelvin. Okay, remember that anything that got to do with steam, that means the highest temperature there is 100 degrees Celsius. That means my final temperature, which is theta 2, is equals to what? 100 degree what? Celsius. Okay, what will I do next? It is very simple. Remember, in heat capacity, there is what we call heat gain is equals to heat lost, right? But in this case, there is no heat gain because the cooling water is losing heat, and the specific heat capacity, no, the latent heat capacity of vaporization of steam is also what? Losing heat. So let me look for the cooling water, heat lost by the cooling water. That's heat lost by what? By cooling what? Water. That's the first thing I need to know. I need to look at, because the cooling water is what? Losing heat, which is what? H is equals to MC open bracket final temperature minus what? The initial what? Temperature. Okay, so my H is equals to, my mass is 0.1 times my specific heat capacity of water is given to us as 4,200 times my theta 2 minus theta 1, which is what? 100 minus what? 25. So I have that my H is equals to 0.1 times 4,200 times 100 minus 25 is what? 70 what? 5. Okay, so my H is equals to 0.1 times 4,200 times 75. I'll have 31,500. 31,000 what? 31,500 watts joule. So I'm done looking for my what? Heat loss by cooling what? Water. So the next thing is heat loss by the latent heat of evaporation of what? Steam. Okay, which is what? My H is equals to what? MLV. So my H is equals to, my mass is what? 0.1 times my latent heat of vaporization of steam is given to us, which is what? 2.26 times 10 raised to the power of what? 6. So my H is equals to, what will I do? 0.1 times 2.26 exponential what? 6. I'll have that my what? 226,000. That's 226,000 joule. Okay, so the next thing I need to look at is my total heat lost. So my total heat lost will be what? That's my HT is equals to, I'll use my heat lost by cooling water as what? As Q1. Okay, plus my heat lost by latent heat of evaporation of steam as Q2, so as which is what? Q what? 2. So my HT is equals to, my Q1 is what? 31,500. 31,500 plus my Q2 is what? 226,000. So 226,000 plus 31,500. Okay, I'll have my what? My HT, which is my total heat lost, is what? 257,500 joule.